Good evening, everyone. Am I audible?
Yes, sir. Good evening, sir.
Yeah, good evening. Is my screen visible?
Yes, sir.
Yes, sir.
So, last class we started with this, no? And I asked you to go through the concepts also. So, I'll just start with these basics and then we'll try to solve some problems based on continuity. Okay. So, listen. So, I gave you an outline of what continuity and differentiability mean. So, continuity means you're trying to check whether a given function is continuous at a given particular point in the domain of it. Differentiability means you are going to check whether it is differentiable at a given point. So, about differentiability, we'll discuss next. So, last class, we saw what is continuity. So, when can you say a function is continuous? A function is said to be continuous when limit extends to C, f of x is equal to f of c. So this is when you will say that a given function is continuous at a given point C, right? This is one way. And we also discussed this thing also. So more elaborately, what should happen is the left-hand limit, the right-hand limit, and the value of the function at x is equal to C should exist and should be equal to each other. Then f is said to be a continuous function at x is equal to C, right? And so I hope you remember all these things. I told you one method also, limit x tends to C minus f of x is equal to limit h tends to 0, right? So with all those knowledge, we will start solving the problems. But before that, I want to know from your side, is there any point that you want me to repeat? Is there any point that is not clear? Is there any point that is not clear?
No, sir.
Okay. So look at the first problem. Check the continuity of the function f, which is given as f of x is equal to 2x plus 3 at x is equal to 1. So how is the solution for this going to be, right? So according to your 12th standard concept, limit extends to C, f of x is equal to how much? Limit extends to 1, f of x, which is going to be 2x plus 3. So what is going to be the answer here? X tends to 1, you're going to substitute this, answer will be 5, right? So let this be equation number 1. What is f of 1? F of 1 is f of 1 is 5. Am I right? So f of 1 is going to be 5. Let this be 2. So if you observe, limit extends to 1, f of x and f of 1, they both are generating the same value, 5. So what can you conclude from this? The function is continuous at x is equal to 1. It is a meaning. Is the point clear?
Yes, sir.
Yes, sir.
Yes. Okay. See, this is how you need to solve problems, but I want to give you a better perspective of what it means. For that, observe, if you do it according to the 11th standard concept, what I'm trying to say is, limit extends to 1 minus f of x is equal to limit, what should you change that extends to 1 minus 2? Limit h tends to 0 and you will write it as f of 1 minus. You will write it as f of 1 minus h, right? This will be limit h tends to 0, 2 into, so you have 2x plus 3, right? So in the place of x, you will substitute 1 minus h. You have a plus 3 already. Okay. So it's going to be limit h tends to 0, 2 minus 2h plus c. Okay. Is that point clear? It is going to be 2 minus 2h plus 3. So what will it be? Limit h tends to 0, 5 minus 2h. Now if you substitute this, answer will be 5. Right. Similarly, you need to do for limit x tends to 1 plus and then follow the same procedure. See, actually speaking, you need not do all these things, but I'm just trying to give you a perspective out of this. 1 minute. Okay. So similarly, if you do limit x tends to 1 plus and then try to solve, you'll still get the answer as 5. Okay. 1 minute. Sorry, guys. So listen. See, what is the function given here? F of x is equal to 2x plus 3. By the way, did I solve this problem? I feel like I've done this. X and y. Can you tell me what is the shape of 2x plus 3 on a graph sheet? What is the shape of 2x plus 3 on a graph sheet? What is the shape of y is equal to 2x plus 3? It is of the form y is equal to mx plus c.
It's a straight line.
It's a straight line, right? So it is going to be a straight line where the y-intercept is going to be 0, 3. Right? So this is where the point 1 is going to be. So at 1, if you check what is going to be the corresponding coordinate here, the answer will be 1, 5. How did I get that value 5? Because that is a function value at that place. So you see that the straight line is continuous from the left hand side as well as from the right hand side, and it has a function value also existing. That is the reason why we say that this function is continuous. Okay. So to put it simple, right, when it comes to exam perspective, you need not do all these things. Exam perspective, these 2 lines are more than sufficient. But when it comes to other chapters where you will need to solve certain problems with respect to differentiability and everything, I would give you only one hint as of now. Any function will be differentiable at a point only if it is continuous. Why is it so? That we'll see it at that point. But listen to this carefully. The name of the chapter is continuity and differentiability, right? If somebody asks you a question of asking you to check whether the given function is differentiable at a particular point, then the function will be differentiable at that point only if it is continuous at that point. So you need to know how to check the continuity. Okay, that is the reason why I'm just giving you different perspectives to think. So having said that, is this clear? So if you look at the solution also, there is the one from your textbook. This is all you need to do. Am I clear? Shall I proceed?
Yes, sir.
Yeah. So now check. Examine whether the given function is continuous at x is equal to 0 or not. Limit x tends to 0, f of x is going to be limit x tends to 0, x square. Substitute this value, answer will be 0. So this is the limit value. What is the function value? F of 0 is 0 square, which is 0. So in this case, again, what is happening? Limit extends to 0. F of x is coming out to be equal to f of 0. Hence, the given function is continuous at that point.
Sir, will there be a case where the limit value, when we substitute the limit value and directly we will get different answers, sir?
Yes, there will be, for example, tan x is there, no? Tan x is there, no?
Yes, sir.
And one more thing is, all these values that you are substituting, x is equal to 0 and everything. If you read the statement again, if you read the statement, it's a good question actually. See, I have shown you a statement. 1 minute. I moved up. My net is little slow. See, if f is a real valued function on a subset of real numbers, and where are we what point are we considering C to be? C is a point in the domain of f. C is a point in the domain of f. Meaning it will definitely be a point in that function. It will be a point which is defining the function at that value. Hence, there is a possibility where you will get a value which is not existing also. We'll see some problems based on.
Yes, sir.
See, for example, if I take this one, discuss the continuity of the function f, where f of x is equal to mod x. Right. Then, first thing that you need to do is define the function. F of x is equal to x when x is greater than or equal to 0. Negative of x when x is less than 0. Makes sense? So f of x is equal to x when x is greater than or equal to 0. F of x is equal to minus x when x is less than 0. So if I have to, so in this problem, I have no other option other than checking the left limit and the right limit. Why? Because the function is broken on either side of 0, whereas in the other two cases, it was not broken. Right? Here, what I'll do is I'll check the left limit. Limit extends to 0 minus f of x. What should I write it as? Limit, the steps are same. Limit h tends to 0. F of
Sir, I have a doubt.
the 0. Yeah, tell me.
Sir, what is like broken? Sir?
See, it is taking two different values, right? F of x is x when x is greater than or equal to 0. This, how to break it, I have already explained in the functions chapter itself.
Okay.
Meaning, this mod x is broken into two parts on either side of 0. That is the meaning of. So when x is greater than or equal to 0, you call the function to be plus x. When x is less than 0, you call the function to be minus x. They are broken, no? That is the meaning. So limit
Okay.
x tends to 0 minus f of x is equal to limit h tends to 0 f of 0 minus h. Now, which function should I take? For 0 minus, which function should I take among x minus x?
Minus x, sir.
So, limit h tends to 0 minus of 0 minus h. Why minus? Because there is a minus here. Minus of, in the place of x, you will put that 0 minus h. So, what will you get? Answer will be 0 only. Okay. Similarly, limit x tends to 0 plus f of x is equal to limit h tends to 0 f of 0 plus h. So, limit h tends to 0 f of 0 plus h means I will take this x, which is 0 plus h, which will be a 0 itself. So, what is happening is, whether you take the left limit for this function or right limit for this function, both are generating a 0. Then what about the function value? What is f of 0? So here when I have this equal to symbol, f of 0 is going to be again this function. I'm marking with red. So f of 0 is again going to be a 0. So what is happening in this scenario? The left limit is equal to the right limit is equal to the function value. Hence, mod x is continuous at x is equal to 0. Mod x is continuous at x is equal to 0. Okay. Now see. This is how the solution will look like. It is broken into different functions. Limit extends to 0 minus. They skip the steps which I did actually. Limit extends to 0 minus means you will substitute minus x here. The place substitute the 0, you will get a 0. Similarly, limit extends to 0 plus, you will substitute x here, substitute 0, you will get a 0. And function value is 0. Hence, the left limit and the right limit is equal to the function value. That's the reason why it is continuous. Okay.
So
So using the same logic, I want you guys to solve the next one. So,
sir, I have a doubt, sir.
tell me.
Sir, so for the previous question, for any value of x other than 0, the function won't be continuous, right?
It is continuous.
No, sir, for any value other than 0.
It is continuous.
0.
It is continuous.
Sir, but del HS and RHS won't be equal, right? One will be negative and one will be positive.
No. You're breaking this function at which point? At 0. For example, if they ask you to check the continuity of the function at x is equal to 1, at x is equal to 1, what function will you consider?
Positive, more positive.
You will only consider x, no. Whether it is left limit or right limit, you're going to consider only one.
Okay, got it, sir.
Got it? Yeah. So using the same logic, solve this problem. I'll give you 2 minutes time. Solve and let me know.
Sir.
Yeah, they just tell me what is the answer.
Sir, the limit, it's not continuous, sir, because one side will be -1 and one side will be +1, sir. The f of 0 minus h will be -1 and f of x will be 1, sir.
Wrong. It is not continuous is the right answer, but why it is not continuous, the logic is not right. So read the question carefully. You will take f of x is equal to x cube plus 3 when x is not equal to 0. Meaning, when will x not be exactly equal to 0? When you take on the left of 0 or right of 0? Exactly at x is equal to 0, the value is 1. The function is 1. 1 is a constant value, right? So they told it is not continuous at 0. We need to show that. So when I say limit extends to 0, f of x, right? Then look at the way I'm going to solve the problem. Everybody listen to this. Limit extends to 0. What function should I take? Among x cube plus 3 and 1, which one should I take?
1, sir.
You should not take 1.
X cube plus 3.
You will take x cube plus 3 because 1 is taken exactly at 0. See, limit something tending to 0 is not exact value. It is only a closer value. Okay. So I need to take x cube plus 3, and when I substitute this 0 here, the answer comes out to be 3. Am I right? So limit extends to 0 f of x in this scenario is going to be 3. Whereas what is f of 0? What is the exact function value at 0? What should I take? 1. So f of 0 is 1. So in this case, what is happening is limit extends to 0, f of x is not equal to f of 0. Hence, it is not continuous at x is equal to 0. Did you guys understand?
Yes, sir, understood.
Yeah. Check this one. Check the points where the constant function is continuous. So what points will you take where the function is continuous? First of all, whenever you have this kind of a question, the first thing that you need to do is understand what is the domain of this function. So what is the domain of a constant function? So what is the domain of constant function? It is going to be real numbers. So domain of constant function is real numbers. Right? So if I take a random point C in the real numbers itself, if I take a random point C, because whenever I'm asked to check the continuity of a function, I can take a random point in the domain of that function and check it. Suppose I take limit extends to C f of x, then it is going to be limit extends to C. What is f of x in this case? It's k. So what will answer be? Limit extends to C, k is going to give you what answer? Is going to give you k itself, because I don't have any x for me to substitute the value of C. Guys, are you able to understand what I'm saying? So limit extends to C, f of x is going to be C. F of C is also is going to be k. F of C is also going to be equal to k. Since the limit exists at every point, what can you conclude? That a constant function is continuous everywhere. So this gives you an idea that constant function is continuous at every real number. Am I clear with this?
Yes, sir.
Yes. Okay. Sixth one. Prove that the identity function on real numbers given by f of x is equal to x is continuous at every real number. Prove that the identity function on real numbers given by f of x is equal to x is continuous at every real. Meaning, can you? See, first, see, it's very simple. Okay, listen to this. That is one of the reasons I'm repeatedly telling you, for you to master calculus, especially these things, please master functions. Okay. So here, what are they saying? Prove that the identity function on 1 minute. Let me. Prove that the identity function on real numbers given by f of x is equal to x. F of x is equal to x is an identity function, right? What is going to be the domain of this? What is going to be the domain of this?
So real numbers.
Domain is real numbers. So f of x is equal to x is continuous at every real number. That's why they told at every real number. So limit extends to c, f of x is going to be equal to limit extends to c, f of x is x. So c, if you put it here, it is going to be c. Right. Now tell me, what is f of c? F of c is also going to be equal to c. So what can you conclude from this? That the identity function is continuous on every part of its domain. So if I take this to be x-axis, this to be y-axis, this is going to be x dash, this is going to be y dash. Listen to this. F of x is equal to x is going to be a straight line that is passing through the origin, making an angle 45 degrees with the x-axis. So what can you conclude about this kind of a function? It is continuous everywhere. Guys, I'm not able to understand if you're clear or not. From next class onwards, see, I want all your videos to be switched on. This is not how it is going to work. And 3 hours of class and I can't waste my energy like this. Okay, I'm continuously speaking. I don't know, no response. It's really letting me down. Are you able to understand or not? Is it clear?
Yes, sir.
Yes, sir. Yes, sir.
அதே சொல்லுங்க yes or no, at least tell that no, because I don't know whether I should proceed or not. So the second definition is, if at all I say real function, if I what do you mean by real function? Is a function which is defined in the domain of real numbers, or a function which has the domain as real numbers or subset of real numbers is said to be a real function, right? A real function f is said to be continuous if it is continuous at every point in the domain of f. This is what I stressed upon. So whenever you are talking about the continuity of a function, the function should be continuous at every point in its domain. Okay. So having said this, there is a concept of algebra of continuous functions, right? Meaning, if at all I have two functions f and g, right, which are continuous at a real number c, right? I have two functions f and g which are real functions, and they are continuous at a real number c. Then if I give you a function f plus g, then f plus g is going to be continuous at x is equal to c. F minus g will also be continuous at given point. F into g will also be continuous at the given point, and f divided by g will also be continuous, provided the denominator, that is g of c, is not generating a zero. Okay, provided g of c is not equal to 0. Clear with this point? Right.
Yes, sir.
Yes, sir.
Yes, sir. Good.
Yes, sir.
No. Yes. Yeah. So listen to this. So theorem number 2 says something like this. That was definition number 2. Here you say theorem number 2. What they are saying is, if f and g are real valued functions such that you have a possibility to define a composite function. What is composite function? You have a possibility to define f circle g at c. Then g, sorry, if g is continuous at c and f is continuous at g of c, then we can conclude that f circle g is continuous at c. I repeat it, listen to this carefully. There are two functions. One is f, one is g, and both are real valued functions. Now, what is happening is, using the functions f and g, you're able to form a composite function. And that composite function is defined at some point c. Okay, this is the first part of the statement. The second part is, if, so when you write f circle g, you come from the right. F circle g means if g is continuous at c and f is continuous at g of c, then f circle g would be continuous at c. That is the meaning of it. Okay.
Yes, sir.
Okay. Yeah. Now, with all these points, we will solve few more problems. So example 7 says, is a function defined by f of x is equal to mod x a continuous function? What is your answer? Is this a continuous function? So what is your answer? The answer is yes.
Yes.
How will you prove it? See, f of x is equal to mod x is something which we have already done. So what you need to follow the same steps, break it into two functions, right? We already solved it in example number 3, right? Suppose you take c to be a real number, which is less than 0.
Sir, you're not audible.
Am I audible now?
Yes, sir.
Yes. So what I'm trying to say is whether you consider a real number which is going to be positive or a real number which is going to be negative, the function is always going to be continuous. Okay. So you can make a note of this point. See, if there is any doubt, I'm expecting you to ask. If something is not clear, you can let me know so that I'll change the method of explaining that problem. But you have to speak.
Sir,
Clear? So I'm assuming things are clear.
sir, can you repeat this question alone?
Yeah. So which point is not clear? See, it's very simple. Okay. Since mod x, okay, mod x is a kind of function which is broken into positive part and negative part. What we will do is f of x will be negative of x for what values? For all values of x that are less than 0. Means in the domain of real number itself, right? This is a real number. This is where 0 is. On the left of 0, the function is minus x. On right of 0, the function is plus x. I hope that point is clear. When x is greater than or equal to 0. Now, what I'm going to do is, in the negative values of x itself, I'm going to consider a point C, where C itself is negative. Let's say that C can be -1, -2, -1.5, something, but it's a negative number. Okay. Then, according to the definition 1, limit extends to C, f of x means limit extends to C. Now tell me, in the place of f of x, what function should I take? What function should I take? I'll take minus x. Am I right?
Why minus x, sir?
Because it's less than 0. No? X is less than 0.
Okay, sir.
Yeah, when x is less than 0, C is also less than 0. Means when you take a negative number, see, don't look at that less than 0. Whenever you take the real number to be negative, then you will consider minus x for modulus function. So limit extends to C, minus x is going to be minus C. Why minus C? Because if you substitute the C here, you will get minus C. Right? Tell me, what is f of C value? F of C means I'll again substitute C in the place of minus x. I'll get minus C. So what is happening to them? Limit extends to C is equal to f of C. Hence, it is continuous on the left-hand side of 0. Similarly, f of x is equal to plus x when x is greater than or equal to 0 means in this range, right? Whenever I take a positive value of x, which function should I use? Should use x. Now, what I'll do is I'll consider some real number c where that c is greater than 0. Now, tell me one thing. Limit extends to c. F of x is going to be how much?
C.
No, come again. Limit extends to c. What should I take? 1 minute, 1 minute. Tell me, what should I take?
X.
Yes. Limit extends to C, X. And I'll substitute the C, I'll get a C. Am I right?
Yes, sir.
That's it. So what is the function value now? So what is the function value? F of C is also going to be equal to C.
C.
Hence, what can we say? The function is continuous.
Continuous.
Very good.
Yes, sir.
Now
Clear.
you could understand, right?
Yes,
See,
sir.
this
Thank you.
what you need to do for every problem. You need not break your head. All you need to do is just take that C, substitute and C. That's it. So discuss the continuity of the function f of x is equal to x cube plus x square minus 1. Whenever they say continuity, what is the thing I told you? First check for the domain. First question, what is the domain of this function? It's a polynomial function. For a polynomial function, what is the domain?
Real numbers.
Very good. So whenever they say check the continuity of the function, in that domain, what should you consider? Some number C, where that C belongs to the domain of the bigger function. Right? So limit extends to C, x cube plus x square minus 1 is going to give us what? It's going to give us C cube plus C square minus 1. Am I right?
Yes, sir.
So this is equation number 1. What is f of C? F of C is C cube plus C square minus 1. This is 2. So what can you say that they both are? They both are equal.
Continue.
So it is continuous. Because when you say the C, right, that C can be any real number. So by you doing these two steps, what you have indirectly told us that the function is continuous everywhere in the domain of it. Am I clear, guys?
Yes, sir.
Yes,
Can we
sir.
increase the speed? I'm going very slow. Can we increase the speed?
Yes, sir.
See, just to show you the solution, I'm showing the textbook part also. This is what they have done. So function value at C is C cube plus C square minus 1. Limit value C cube plus C square minus 1. They both are equal, hence it's continuous. Okay. Now tell me. Vaishnavi, are you there? Vaishnavi, can I have some response? Sheetala, you're there?
Yes, sir.
Asala, how to do this problem? See, discuss the continuity of the function defined by f of. So what will you do? You will consider a C, a number
A
C.
real number. And then take limit.
Correct yourself. Illa, correct yourself. It's not real numbers. It's real numbers.
Other than 0.
Other than
except
0.
Yeah, because in the question itself, they have given C x is not equal to 0. Okay, so
Yes.
whenever fractions are there, check where the denominator will become 0, eliminate that from the real numbers. Okay, so limit extends to C, f of x is equal to how much?
Limit extends to C 1 by x.
Yeah. Sorry, limit extends to C 1 by. So what will I get?
1 by
I'll get
C.
1 by C. What is the function value? Function value is
F of C, which is C 1 by C, sir. Yeah.
is 1 by C. So what can you say? It's a
Continuous function.
You understood?
Yes, sir.
Simple, right? Yeah. Sai Kalyan, now you answered. Sai Kalyan,
I will do an answer, sir. I will do it in 2 minutes and answer.
you just tell me. You just tell me the steps. I'll write it. No need to do it in your book. Even if it is wrong, nobody is bothered. Okay? Be confident.
Okay, sir.
Discuss the continuity of the function. Discuss the continuity of the function, which is defined as f of x is equal to x plus 2 if x is less than or equal to 1, and x minus 2 if x is greater than. So here what is happening is a function broken or it is given as a single function. Answer the question.
It is broken, sir.
It is broken at which point?
Left of the number line, right of the number line.
You look at the right. No, which number is it broken into two parts? Which is the limit getting
One.
broken? Look at the value of x, no? X greater, it is at 1. Means on the real number system, if I take 1 to be here, on the left of 1, this is the function x plus 2. On the right of 1, the function is
X minus 2.
minus 2. I hope this is clear, right? So, plus 2, I want everybody to listen. X plus 2 and x minus 2, we observe, they're polynomial functions. So, polynomial functions are always continuous. Okay, polynomial functions are always continuous. Means x plus 2 is individually continuous, x minus 2 is individually continuous. Now, this x plus 2 and x minus 2 put together, listen to this carefully, guys. So x plus 2 and x minus 2 put together is what this total function is. So we are not asked to check the continuity of the function of x plus 2 and x minus 2 separately. We need to check as a combination. So x plus 2 individually is continuous, x minus 2 is individually continuous. So when can the combined effect be continuous? Provided these two functions are exactly continuous at 1. For that, in this problem, what I need to do is I need to break the left limit and the right limit. Limit extends to 1 minus. Sai Kalyan, answer this. So when I say limit extends to 1 minus, among x plus 2 and x minus 2, which function should I take? I have drawn it on the right hand side. You will be able to answer it now.
Sir, we should take the first one, x plus 2.
Very good. So you will take this x plus 2. Right. I taught you that steps, no limit h tends to 0. You need not do all those things. So just substitute the limit. So what will you have? So what will you have? Don't substitute minus 1. You will have 1 plus 2. Answer will be 3. Answer will be 3. So what limit extends to 1 plus, guys? Sai Kalyan, tell me the 1 plus. Now what should I substitute?
X minus 2.
You will take
X minus 2.
correct. So you'll take x minus 2. When you substitute the limit, you will get 1 minus 2, which is going to be minus 1. Am I clear with this? So you'll get left limit you got 3, right limit you got minus 1. What is the function value? F of 1 means which one should I take? Look at less than or equal to. Which one is having that equal to? X plus 2, right?
First.
Yes. So what is f of 1?
3, sir.
3.
Very good. So here, is this function continuous? Left limit is equal to the function value, but it is not equal to the right limit. Hence, it is discontinuous. Am I clear with this?
Yes, sir.
So I hope
Yes.
everybody could understand this problem. So it is a discontinuous function. Okay. So make a note of this point. Okay. So here I want to stress on one more point. See, here you have this 1, right? On the left of 1, what is the function? It is x plus 2. So x plus 2 is a straight line, right? Like this. And at exactly 1, it is continuous. Means from the left of 1, it is continuous. It's a left continuous function. Whereas the other function x minus 2 is there. No, at 1, it does not have a value defined. And the graph for it is going to look something like this. So are you able to understand that there is a break in the graph that you draw? Are you able to understand that there is a break in the graph that we draw? Hence, this kind of a function is discontinuous. But what kind of continuity does it follow? It follows the left continuous function. Am I clear?
So can you say like the
Right.
break again, sir?
My voice is breaking. Huh?
No, sir. Like you said, the graph is like breaking. That explanation.
Graph break. Graph is breaking. No, see, the graph would have been continuous. For example, had it been like this. See, this is the point 1. Okay, this is the point 1. So what is happening from the left? There is a graph that is coming like this, and it is continuous at this point. Had this graph started from this point, it would have been continuous.
Okay.
But what is happening? It is not. See, simple term. The second graph is not starting from the point where the first graph stopped. Correct?
Yes, sir.
Are you able to observe that point in the graph
Yes,
sheet?
yes, sir. Yes, sir.
So that is why it is discontinuous. That is why it is discontinuous.
Okay, sir.
Got it? Yeah.
Yes, sir.
So we'll do one last problem and then wind up. This one. So example 11, find all the points of discontinuity of the function. Whenever you have this kind of function, again, the function is broken, right? Divya Rupa, you're there?
Yes, sir.
Yeah, you tell me how to solve this. So this function is broken. At which point? This function is broken at which point?
At -1, sir.
Look at the x values. No, x is less than 1, x is equal to 1, x is greater than 1. So what is the limit value? I mean, where is the function broken? That it's if you observe this itself, you will be able
1.
to, it is broken at 1, not at -1.
Sorry, sir. 1.
No problem. So it is broken at 1. So whenever the function is broken, you have no other option other than checking for the left limit, right limit, and the function value. Okay. So if I take limit x tends to 1 minus, among the 3 functions that are given to us, which function should I consider?
X plus 2.
Yes. So if I take x plus 2, I'll substitute this 1 directly. So what will the answer be?
3.
Very good. Similarly, limit x tends to 1 plus, what function should I consider?
X minus 2, sir.
Correct. No. So what should I do? Substitute this 1 here. What will the answer be?
1. -1, sir.
It is -1. What is the function value? F of 1.
Zero.
It is 0. So what is happening in this case is, theoretically, by now you would have understood what kind of function is this. Is it continuous or discontinuous?
Discontinuous.
It is discontinuous, obviously, because none of them are matching. So x plus 2 is going to be a graph like this. So my limit is 1. So x plus 2 is having an open circle at 1. X minus 2 is having an open circle at 1. And f of 1 is 0. This is how the graph will look. Am I clear?
Yes, sir.
Is everyone clear?
Yes,
You're
sir.
able to get a grip of what discontinuity and continuity means?
Yes, sir.
Yes, sir.
Okay, that's good. Right? So the remain, so this is how, see, this is how it looks. They have shown it. See, actually here they should have put a dot like this, because f of 1 is 0. Okay. So similarly, you'll have many such functions where the function will be broken and you can solve it. Tomorrow's class, I'll be doing maybe 3 to 4 problems, post which I'll go to the concept of differentiability. Okay. So for the remaining set of problems, right, in exercise problems and all, I have already solved it and put the video in the app itself under the pre-recorded videos. So I'll be giving that as homework and you can have a look at those videos and solve it. If at all you have a doubt, look at it or else solve it on your own. Is the point clear?
Yes, sir.
Yes, sir.
Okay. So let's wind up.
Thank you, sir.
Yeah.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.